Williams. I'm the engineering director in our aerospace business of fluid and electrical distribution. So my responsibilities include leading the global engineering team. So I have about 150 engineers focused on supporting our division by managing our new product development and new product introduction. We also focus on research and development, new technologies, new processes, new materials. And then we also support our current existing products throughout the life of the aircraft. And then we look for opportunities to support our customer throughout the service life of their aircraft as well in our aftermarket business. So the engineering team has a play in all these different aspects of the business. So as Gail mentioned, I've been with Eaton for 15 years and I'm currently located in Jackson, Michigan. My background, I have a chemical engineering degree. So I received that from Michigan State University, and I also have a master's in business. A couple of fun facts about me. So I have some hobbies, Michigan seasonal. So I do golf in the summer and I ski in the winter. My nerdy fact about myself, which hopefully some of you science and STEM individuals will be appreciating, is I actually have spent the last month or two watching all the Marvel movies in chronological order of the events that they occurred. So not their release date, but the events of the movie. So just finishing up that one with the last Spider-Man movie. So it's quite an accomplishment for myself and my teens.
So my name is Mennis, and I'm the general manager for our conveyance business. I'm not going to tell you what I'm watching on Netflix right now. I don't have a good story. But I've been with Eaton, as Gail said, 23 years in various roles, mostly in our sales and our program management organization. And I've been with Aerospace with Eaton for about 19 of those 23 years. Currently in my role, I am the general manager for our conveyance business. And this is really, conveyance is all about moving fluids across the aircraft, whether it's hydraulic fluids or fuel, but moving that the fluid across the aircraft. You can call us the plumbers of the aircraft if you so choose. But I'm responsible for the business profitability, managing the customer issues, certainly working with Kelly's teams to solve those issues, developing our product line strategies, and really kind of driving growth. Funny, when Kelly and I were putting this together, I laughed because you see two people in aerospace with chemical engineering degrees in a mechanical and electrical business. So it kind of, I don't know how that worked out, but it was funny that we put that together on this slide. But I did get my chemical engineering degree from University of Virginia. Kelly put the year she graduated. It made me sad when I put mine on there, so I didn't want to do that.
I don't know how that got in there.
And then I did get my MBA from the University of Michigan, the Raw School of Business. But my fun fact is I spent a lot of time at my children's activities. One of the things this weekend is all about travel hockey tournaments. So I'm really pleased that I was able to find time to join this because I think this is a really great event. But my son's first tournament starts at 1 o'clock. So we're really good from a timing standpoint. So if you don't mind going to the next slide, I'd like to really quickly, Gail kind of gave you the high-level overview of Eaton as a corporation, but I wanted to tell a little bit more about Eaton Aerospace and who we are as an aerospace business. So while Eaton has focuses on the electrical business in general, or our vehicle business, even some of our industrial hydraulics, as an aerospace group, we're about a $2 billion business. We have 8,500 employees globally. With, as you can see, numbers of global facilities. But I also wanted to highlight our two locations in Michigan. We have a facility in Grand Rapids and a facility in Jackson, but that Kelly and I are both based out of. When you look at Eaton Aerospace and who we are and what our products are, we kind of look at our core products in 6 primary areas. When you think about airframe pneumatics, this is about moving air from the engines across the aircraft and using that to help control the environment. Our electrical power is about moving power distribution across the aircraft, and even doing a lot of distribution of that. We are also doing power conversion from some of our core products out of one of our facilities. Our motion control is about actuation, moving things on the aircraft up and down, or even whether it's hydraulic actuation or utility actuation, or even in the landing gears. Our engine solutions are all about building components around the engine. So our engine buildup, as well as we have the leading engine fuel pump, as well as some of the key fittings that go on the engine. Our hydraulic systems, we like to think of ourselves as a one-stop shop for our hydraulic systems because we offer all the major components, again, as well as the distribution to create that system on an aircraft. And then fuel and oxygen is all about fuel distribution, as well as aerial refueling. So those are our 6 core products. The best part about our products is they're virtually on every aircraft in the industry. So I kind of put some pictures at the top to try to show you some of the areas of where our products are used, but you can pretty much find an Eaton product in any aircraft that's flying. We're about 50% commercial, about 40% military, and about 10% more in the other, more the space, maybe ground transportation for military and defense. So really kind of in all those different platforms. But the most exciting part about Kelly and I's job is about what we're doing today to try to put our products on today's aircraft, but also about how to position our products for the aircraft of the future. So when we think about what we're doing today, whether it's for tomorrow or 2050 or 2050 and beyond, we're innovating for the future, considering how we're going to put our products on the more electric aircraft and how to put more electrics in our aircraft. What does that do to our hydraulic system? How do we make that more of a electrical, mechanical hydraulic system? How we are designing our products using additive manufacturing, and how we're incorporating digitalization and the Internet of Things. So for us, that's the most exciting part about our jobs, is about really trying to find solutions for our customers, knowing that when we win on those aircraft that are flying, that you're flying on, where our military is flying on. So this is a really great opportunity for us to see our work being put into action, whether today or for the future. So Kelly, I'll turn it over to you to do the introduction for our next speaker.
Thank you, Amy. So I have the opportunity to introduce Ms. Wei Kim Tran. So Ms. Tran is the Director of Aeronautics at NASA Ames Research Center, providing technical and management oversight of research disciplines in air traffic, aerospace simulation and operations, autonomous systems, computational fluid dynamic analysis, vertical flight technology, experimental fluid mechanics, and wind tunnel operations. She manages an annual budget of over $200 million and is responsible for the work of 600 staff across 12 aeronautics projects. Ms. Tran is also responsible for the safe operation of the world's largest wind tunnel. At the agency level, Ms. Tran serves as the Ames Aeronautics Research Director, working closely with the Office of the Associate Administrator and its program directors, providing strategic plan and directions for aeronautics. The products of their work is highlighted in several critical initiatives like Low Boom Flight Demonstrator, the UAS Air Traffic Management, Aerospace Technology Demonstration Project, Urban Air Mobility, and University Leadership Initiative. So I'd like to welcome Ms. Tran.
Good morning. Good morning, everyone. I am so pleased and honored to be able to speak with you this morning. You can see from my chart the picture of the low boom Supersonic Demonstrator. This is one of the activities that we are working with our partner to be able to reduce the boom when the aircraft travel at supersonic. One of the reasons that supersonic travel has not been coming to the public because of the boom noise over land. And other aircraft that you see are different configuration that we are looking at for the future. And also we're also looking at more electric aircraft or electrified aircraft. So with that, please go to the next chart. Great, thank you. So before I start where I work, I want to just quickly tell you who I am. I am an immigrant. I came to this country in 1980s, so as a teenager, and I started working as soon as I got here as a nurse aide at night and a farm worker during the day. We moved to California, Northern California, and I went to junior college because I did not go to high school here or completed high school here, and got the bachelor degree in material engineering at San Jose State and a master degree in mechanical engineering. So when I was a student, I got an internship at NASA Ames, and I have been here ever since. I love to work for NASA. NASA is my dream come true. So I'm not planning to leave it anytime soon. This is where I work. It's in Silicon Valley. Most of you probably know it's next door to us, the big Google campus. To our south is Apple campus, and then to our north is Facebook. So we're actually in the midst of innovation. A lot of innovative companies are here. We have about 2,400 employees between civil servant. Civil servant is somebody working for the government like me. And then we also have about 1,200 students. This is the number of the students that we have prior to the pandemic. As you can see in the picture, that there is the larger piece of the building that you see that is the largest wind tunnel in the world. We also have the second largest wind tunnel in the world. So at Ames, we have a couple of things that we can claim fame there. So go to the next chart, please. All right. So what do we do? So NASA Ames is the second NASA center in the country. The first center is at Langley Research Center. Ames was started in 1939. After Langley established, the government wanted to make sure that they have another center that is not in the East Coast. So Charles Lindbergh actually came out to the West Coast and choose Moffett Field as the second NASA center. We as an aeronautics center, we've done a lot of research in aircraft design, and testing them. That's why you see we have quite a bit of wind tunnel, and our sister Langley Research Center also have a lot of wind tunnels. So we essentially were duplication of Langley in the West Coast. But over the years, as people said, we're in the West Coast, so we tend to be a little bit non-conforming. So we start looking at other area of research besides just design and testing new aircraft configuration. We're looking at the air traffic management. When you fly today, all of us, when you fly today, we actually are flying with you because all of the tool and technology that the FAA used to manage the traffic is come from the research that we do. We have a strong relationship with FAA. We do the research, and we transfer that technology to the FAA so that they can deploy in the country. The second area that we work on, and where I actually came from as a student and also as an engineer, is entry system. entry system address issue when you coming into the atmosphere. So anybody launch anything out to outer space, when they have to come back, they need to come and talk with us, because without our entry system, such a material, heat shielding material, and then you're gonna need to protect your aircraft, a spacecraft to come in. When Janelle talked about this afternoon, probably mission to Mars, actually NASA Ames worked on all the entry system for Mars entry. I actually work on all of the Mars entry, even today. From where I'm standing, I'm a management team, but on the side, I do differ with the technical work. So that's my love for as far as professional. Since we're in Silicon Valley, we actually pioneer in the advanced computing. Ames, NASA Ames had the first high-end computing that providing computing power for Earth simulation, for computational, for aircraft, aerodynamic, thermodynamic, and many more. Right now, we have quite a bit of advanced computing activities that we support Earth, space, exploration, and also in aeronautics, and the lunar exploration initiative that that NASA is currently working on. The next area that we work on is what we call is adaptive system, adaptive intelligence system. Eventually we're going to need to have the machine that is smart and know how to manage itself, know how to fly, just like the autopilot or autonomous driving that you see on Tesla car this day. And in the area that I'm actually very interested in is the aeroscience. Now, aeroscience means that the science of aerodynamics or aerothermal. And the picture that you see down there, where you see the two aircraft with the shock emanating from its body, that's what aeroscience does. And the high-end computing that I talked earlier, actually, the capability used in this for us to simulate the flow field around a subject or an aircraft. And then, of course, we talk about astrobiology. We have a group of people that worry now in looking at, is there life in the universe? So that's exciting. And also, they also working with JPL on looking for life on Mars. Go to next slide, please. So some of the, I want to talk a little bit about some of my favorite projects that I work on. Besides, I work on the Mars mission. I also work on the project called Stardust Sample Return project, and it is a space. NASA sent out a spacecraft to a comet, take a lot of picture, doing a lot of science, but we also collecting sample. And what you see here is the sample return capsule with a tennis bracket filled with aerogel, and that's where we capture the comet dust at its tail, and then we brought it back to Earth. This is the first time that NASA ever brought back anything from the interstellar planet, and actually it's the highest Earth entry ever attempted. And right now it is in display at the Air and Space Museum. in Washington, D.C. So next time when you go to the Air and Space, you can see it's sitting there. And my contribution to this project is the heat shield at the bottom that protecting the comet symbol, bringing back to Earth. So I'm very proud of that, of that project, and it's successful. It's like my third child in my book. But my other favorite currently is flying and managing drones. So you hear about drone flying and either deliver good or medicine or surveillance on pipeline or electrical grid. Managing them is important. When we have thousands and thousands of these drones flying in the future, we need to make sure that they all be able to manage autonomously. The FAA cannot have enough air traffic controller to manage them. So we came up with a different framework and a different architecture on how to manage this drone. My other favorite project is testing and designing new aircraft. And the picture that you see there is in the Transonic Wind Tunnel. And so we're looking at many different designs throughout the year to see how can we reduce the fuel burn and therefore reducing the emission and help to and help to reduce the fuel burn, the CO2 that aircraft exhausting. We also looking at electric aircraft that you might be able to hear later in other panels. So with that, I'd like to thank you for the opportunity to talk with you about what I do, what some of my things that I've done at NASA Ames, and what is NASA is all about. So thank you so much.